So the focus of topic 3 is equivalent fractions. So let's start with some definitions and maybe a little bit of a visual understanding or example to understand this. So fractions that represent the same portion of a whole or the same point on a number line are called equivalent fractions. So let's say we have two Hershey's bars, just the plain old regular Hershey bar. So this is Hershey bar number 1. Pretend this is exact. Okay, I'm not exactly an artist. And so we've got a second Hershey bar. This is going to be Hershey bar number 2. So my Hershey bar is broken into 2 pieces, okay? And I eat one of those 2 pieces. So I eat 1/2 of my Hershey bar, okay? Let's say Hershey bar number 2 goes to you, and your Hershey bar was split into 4 equal pieces, and you ate 2 of them. So you ate 2/4 of your Hershey bar. Did one of us eat more or less than the other? No, we both ate the exact same amount of chocolate, okay? So because we ate the same amount of chocolate, that means these 2 fractions, 1/2 and 2/4, are equal to each other. So they represent the same amount. They look different, but they represent the same amount, okay? Now, to determine if 2 fractions are equal, we can compare cross products. So when we're talking cross products, if we're looking again at 1/2 and we're saying, okay, we think 1/2 is equal to 2/4, we would cross multiply. So multiply the first numerator and the second denominator. First denominator, second numerator. Those are called, that's cross multiplying. But the product you get on each side, those are called cross products. So does 4 equal 4? Yes. If the cross products are equal, the fractions are equal. Okay? So we're going to practice determining if fractions are equal, but we're also going to look at creating equivalent forms of fractions. So to create equivalent forms of a fraction, multiply the numerator and denominator by the same natural number, okay? So let's go ahead and look first at determining if pairs of fractions are equal. So example 5 for this worksheet says determine if each pair of fractions is equivalent. Well, remember, we can cross multiply and compare cross products. So we take the first numerator and the second denominator, so 4 times 15, and we want to see, does that equal the first denominator times the second numerator? So does that equal 6 times 10? Well, you may need a calculator, so get a calculator out if you need one. I happen to know that 4 times 15 is 60. I also know that 6 times 10 is 60. 60 times 60 is equal, so those cross products are equivalent, so the fractions are equal. So the fractions are equivalent. Well, it'd be cool if I could spell equivalent. Equivalent. All right, so let's look at example 5, part B. So again, we're going to cross multiply, so that's one numerator, the opposite denominator, one denominator, the opposite numerator. So like so. So I'm going to take 2 times 15. I want to know, does that equal 5 times 7? Well, 2 times 15 is 30. 5 times 7 is 35. These cross products are not equal. If the cross products are not equal, the fractions are not equal. So no, the fractions are not equivalent. So that's a quick, very easy test that you can do to see really, like right off the bat, if 2 fractions are equivalent or not. Now let's look at example 6. So for example 6, it says determine 2 equivalent forms of each fraction. So remember, if we scroll up just a little bit in the worksheet, we had that to create equivalent forms of a fraction, multiply the numerator and denominator by the same natural number. So if I want to find an equivalent form of 3/4, I multiply the top and bottom by the same number. And there's a reason for this. So let's say I want to multiply the top and the bottom by 2. Well, if you think about this, 2 divided by 2 is just 1. So 2 over 2 is just 1. So it's like we're coming up with a nice version of 1. And if you remember, multiplying a number by 1 does not change that number. So even though we're multiplying 3/4 by a weird version of 1, we're not changing the value of 3/4. We're just changing the way it looks. So 3 times 2 is 6. 4 times 2 is 8. And if you want to double check yourself, we know how to check to see if two fractions are equal. I would take 3/4 and determine, hey, is this really equal to 6/8? I cross multiply, so I would say, does 3 times 8 equal 4 times 6? Well, 3 times 8 is 24, and 4 times 6 is 24. So that verifies that these two fractions really, truly are equal. Okay, now we need to find another equivalent form of 3/4. So we could take 3/4 and multiply it by any natural number. So let's say we decided to multiply top and bottom by 7. So again, 7 divided by 7 is a weird form of 1. Multiplying 3/4 by 1 does not change its value. So we would get 21/28. And you could certainly check that. We would say 3 times 28 equals 4 times 21. Let me double check here. 3 times 28, we could do the side work, but for the sake of time, we're going to cheat and use our calculator. So 3 times 28 is 84. 4 times 21 is also 84. So we can verify that 21/28 is equivalent to 3/4. Okay, let's do the same thing for 6/11. So I take 6/11 and we can multiply it by any natural number. So if I was in the classroom, I'd be like, let's think of a natural number, and people would shout it out. But let's say we multiply top and bottom by 3. 6 times 3 is 18. 11 times 3 is 33. If you wanted to check, we could cross multiply. So we want to know, does 6 times 33 equal 11 times 18? And again, for the sake of time, instead of doing this by hand, we're going to cheat and use our calculators. Get your calculators out. 6 times 33 is 198. 11 times 18 is also 198. So we just verified that we really did come up with an equivalent form of 6/11. Let's do one more. Let's say we multiply the top and bottom by 8. I'm just pulling these numbers out of thin air. Again, if we were in the classroom, this would be kind of more of a group discussion. Well, 6 times 8 is 48. 8 times 11 is 88. Let's double check just to be certain. So 6 times 88, we want to know, does that equal 11 times 48? Well, 6 times 88 is 528. And 11 times 48 better be the same, and it is. So we verified that we have another equivalent form of 6/11. So finding an equivalent form of a fraction is really easy. Just multiply the top and bottom by the same number, which is secretly multiplying by 1. And we know that when we multiply by 1, nothing really happens. So we're just changing the way the fraction looks, but we're not changing its value.